Question 7, lots to read. We've got a straight line graph to look at to begin with. I mean, this is literally find the equation of the straight line. And you know that normally a straight line will be y equals mx plus c. So let's find out the gradient. The gradient is, it's almost a straight line, isn't it? So how far up does it go? It only goes 0.4 up. And how far along does it go from 1 to 20? So the gradient of this is 0.4 divided by 20. 0.4 divided by 20 is 1 over 50. So I'm going to put the 1 over 50 in there. I can also see c is the intercept. The c is going to be 2. And these aren't y's and x's, are they? It's not y. It's log to the base 10 of p equals 1 over 50. It's not x, it's t plus 2. So a straight line equation sort of there. Part B, find the initial number of red squirrels. So the initial number is when t is equal to 0. So when t is equal to 0, we get log 10 of p equals 0 add 2, which is 2. So p is 10 to the power of 2, which is 100. So the initial one was 100. Part C now says find this complete model here. And maybe, we could try and figure it out from what we already know p is 100. It tells me that the a value there is 100. But let's show you how. I'm going to work with this bit here now. And what I'm going to do is I'm going to do 10 to the power of both sides. So I get p equals 10 to the power of 1 over 50t plus 2. I'm going to play with some powers now. So p equals 10 to the power of 2 times by 10 to the power of 1 over 50t. 10 to the power of 2 we know is 100. And 10 to the power of 1 over 50. Well, 10 to the power of 1 over 50, a tap in the calculator gives me 1.407 all to the power of t. There's the answer there. There's an alternative way of doing it by sort of doing unwrapping and working towards it, but that was quite straightforward, I think. While I was doing that, I did do 10 to the power of 1 over 50 to 4 significant figures. I was careful with that. Part C. Use this information to show it's not valid in 2019. So 2019. So 2019, t equals, let's check. We've counted wrongly before, haven't we? Where are we going from? We're going from 1996 to 2019. So t is 23. Count on your fingers if you're not sure. Put a 23 into the model. P equals 100 times by 1.047 to the power of 23. That gives me that P should be 288.4 of a red squirrel. Don't know what 0.4 of a red squirrel is. But this does not equal 198. So therefore not valid. In fact, it's a very long way out, isn't it, by then? Suggest a reason why it's not being modelled. So it might be a predator. Someone came and ate the red squirrels. It might be grey squirrels coming in and knocking out the native red squirrels. It might be disease. It might be they moved away. It might be a motorway a road was driven through the wood, and I don't know. A real life reason why it hasn't